Assalamu alaikum. In this lecture, I am going to explain you two type of important filter: image smoothing and sharpening filter, which are very much important in image processing. My topics cover image processing, what is image processing, image representation, then special filters, then smoothing to remove noise, and sharpening to remove the blurring. At the end, some references. Let us start the presentation. Image processing. What is image processing? Image processing is a method that we perform on image to get some suitable information or enhance the quality of any image. It has application in all walks of life, in medical image technique, robotics, document analysis, surveillance camera, if you do some analysis, video analysis, 3D scanning, almost everywhere. Image processing has application, motion capture, games, effects in a movie, everywhere. Image representation. So first we understand what or how we represent an image mathematically or digital. First, we can represent an image like a matrix. It's an array of number, two-dimensional array, x and y direction. So you can see an image and its matrix representation, and the digit you are seeing is the intensity. There are different format for image: PGM, portable gray, map, GIF, JPG, mod is a modern version, and many other exist. Image as a function, you can consider image as a function. Intensity, in terms of intensity equal to a value, or you can write f row column entry equal to a value, that is the intensity. Color image is a vector. It is a array of three numbers: red, green, blue, and image intensity typically between 0 and 255. This is an example. You can see a neighbor of an image, and this is 7 cross 7 image. Pixel value you can see is 94, and the maximum pixel value is here 96, and the minimum is 0. Between 0 and 255, 0 mean jet black, and then different shades of white. Image as other representation: binary image, grayscale image, color image, and many other. Consider the following image. It has 2724 into 2336 pixels. It is an 8-bit representation. As I mentioned earlier, 0 mean black, 255 mean pure white. This is a pixel. Its location is 11 and its intensity is 103. And this corner picture representation is 2724 times 2336 and 88 its intensity value. This is also a neighborhood of pixels, 7 cross 7 neighborhood. Color image also has, I already told you, 3 different shades of red, green, blues from between 0 and 255. You can see at the top 90 for red, 0 for black, red, green, and 53 for white. Noisy image. Noise happen for many reasons, including poor lighting conditions. If you remove noise, you need smoothing filters, or we call it a smoothing techniques. Here you can see a noisy image pixel value and the true image pixel value in that neighborhood. True image pixel value is 255 and the noisy image at the same place is 20.7. For blurry, if you remove blur, it's this technique called image sharpening. Blurry also occur due to many reasons. Sometimes camera shutter is open or the object is moving, so you get a blur. Image sharpening technique used to remove the blur. Special filter means space related filter. I will tell you information of about space related filter. Filter, space related filter, you can see here the input image, you will apply some filter. It is an operator, so you will get output image. So you have to take care two things. Special filter work on the neighboring pixels and do operation on the pixels, mathematical operations on the pixels. Usually they have square shape, like this is a 3 cross 3 pixel sorry filter. We also called it window. And operation, mathematical operation, you can see this 3 cross 3 filter has this operation: 5z1 minus 3z2 plus z3 minus z4 minus 2z5 minus 3z6 plus z8 minus z9 minus 9 times z7. So it locate value in the center. Usually filter relocate value on the center, on the neighborhood where they applied. Linear versus nonlinear filter. You can A filter is called linear when the operator being used in a linear combination, otherwise non-linear. Like the first one is a linear, it's a linear combination, and the second maximum is not a linear combination, so it is a non-linear. Two common linear operator applied on filter: correlation and convolution. What is correlation? Correlation, you will put a filter on a specific region, then you do element wise multiplication, then you add them and do the output on the center of the filter, like in this example z5. So this is correlation. So you will apply correlation step by step on the side on a complete image, and then you do the scaling operation and do the summation and locate the output pixel value in the filtered image. This is a matrix representation of the correlation. When you apply correlation or a filter on the boundary, so you need ghost pixels to apply the correlation and get the output value. So this is called padding. Mostly ghost pixels value has 0, so they do not contribute in the output. Often used in application where we need the measure the similarity between images. Simple template matching does not work in the most real case. So instead of correlation, most powerful is convolution. Convolution is just like a correlation, but before that you have to flip the both horizontally and vertically the filter, then apply correlation. If the filter also called window or matrix has the symmetric structure, so convolution is same like a correlation. So this is the mathematical form of a convolution. So this is a comparison. You see, first we apply correlation, so the output image has 987654321 pixel value in the middle. When you apply convolution, first you flip horizontally and vertically the filter, then apply correlation, so the resultant has a different pixel value: 1 2 3 4 5 6 7 8 9. Filter category which we discussed: first is smoothing, second is sharpening. Smoothing low pass filter we call them, and sharpening high pass filters. Smoothing filter used to remove noise. It has to information first. The mask or the filter element should be positive, and the mask element sum to 1. If you sum them, or if you do the average of that, so you will get a total sum 1. Here is an example of Gaussian filter 7 cross 7. This is an example. Input image has a noisy structure, so after smoothing you have a more smooth image. In both example, look at in the bottom, there is very less noise, so when you apply, so you will get extra smooth. Sometimes smoothing is not helpful. So smoothing filter emphasis on a fine detail. The element of the mask contain both, sorry, shortening filter do use for deblurring. The element of the mask contain both positive and negative weights, but in smoothing case you see all should be positive and the sum should be zero here in sharpening filter. Sharpening filter mostly work on edges. This is the result of sharpening filter. Input image little blurry, and after applying sharpening filter you have more sharp image, more clear scene. Particular example of smoothing filter are averaging, Gaussian, median filter. First two are linear, last is non-linear. This is the example of averaging filter. First is 3 cross 3, then 5 cross 5, and then 7 cross 7. So this is the average. You see 3 cross 3 has 9 elements, so you average them by dividing 9. This is application of smoothing filter, averaging smoothing filter. Original image, then 3 cross 3, then 5 cross 5, 7 cross 7. If you increase or apply a high size smoothing average filter, you see you have extra smooth result, like in the case of 25 by 25. Second is Gaussian filter. It represents as a Gaussian distribution or follow the Gaussian distribution. 7 cross 7 Gaussian example is this one, and the representation as a Gaussian distribution. Mass depend on the sigma. For example, in this example, 68, 95, 99.7 rule. So these are two example. 7 cross 7 it has Gaussian standard deviation is 1.4, and the 15 cross 15 has standard deviation 3. So this is the application of a Gaussian filter. With small Gaussian you have limited smoothing. It's large Gaussian you have strong smoothing or extra smoothing. Average bursting Gaussian, so average does not play good role. Gaussian do some better result, but it depend on input image, what type of smoothing you need. In some example averaging is better, in some example Gaussian is better. Median filter, mostly used to remove salt and pepper noise. The noise you are seeing like this one is called salt and pepper. There are many type of noise. One of them is salt and pepper noise. So you do apply a median filter to remove it. Median filter is simply, this is the result of averaging and this is the result of median. Median mean a statistical operation. You list the element and get the median value by arranging them in an increasing or decreasing order. This is what median filter, if you apply on this neighborhood, their pixel value is 10, 20, 20, 15, 99, 20, 25 and 20. You list them in increasing or decreasing order, you get a median value and place it on the center of the output image. Sharpening filter for using deblurring. Most common are unsharpening, high boost filter, gradient filter, Laplacian filter. Unsharp masking or high boost filter. First obtain a sharpening by subtracting a smooth. First you apply smoothing, apply a smoothing filter, low pass filter. Then you subtract it from the original image. So you will get a mask that is called sharpening mask. Then you see here you have our original image, text image F, and then you apply some smoothing filter FLP, and then you subtract, so you will get a Gaussian mask. But so image shortening emphasizes edge but detail are lost. Add a weighted portion of a G mask back to the original image. When you get, after getting, first you apply a smoothing filter, then you get a mask, then you again add it to a original image, then you get the resultant sharp image, like in this one F, here G mask which we get in the previous slide, and you will get a resultant G XY image. Here K is the multiplicity. For K equal to 1, process is known as high and sharp masking. For K greater than, this is process called high boost filtering. In 1D example, you say original image, then you have a blurred signal. So what you do, you will do unsharp masking. First you do the smoothing, then add it to the original image, so you will have a sharpened signal. Studio example, original Gaussian smoothing. Remove just noise, then get the sharp by subtracting from the original. Then unsharp masking, add with multiplicity 1. High boost filtering, add with multiplicity greater than 1. So these are the result. With high boost you have a good result. So a derivative filter, you can involve the derivative to get the filter. It may result in a sharpened image. Image derivative can be computed. This is, we know, mathematically gradient. The gradient is a vector which has magnitude, we already know, and direction. So gradient may provides information about the edge strength. So it give us the information about the edge direction. Gradient direction perpendicular to the direction of the edge, used for tracing the object on the boundaries. Or you calculate the gradient, you do the numerical approximation, you apply a difference formula. This is the limit, mean the exact definition, then approximation if you remove the limit. So this is the first derivative, approximation in x or y direction. So here if you just apply first derivative approximation on the pixel, these are the result in x or y direction. If you simply do in x direction, the first image, if you do in the y direction. So these are important to visualize the structure of the image. And gradient is helpful understanding the edges. So there are many approximation of the gradient. Some are listed here. minus 1 and 1 in x direction, 1 over minus 1 in y direction. So gradient mostly calculate not on the edges, in between the edges, or on the derivative in x direction on x edges, in y direction of y edges. If you want to calculate the derivative, first derivative on the same location in x or y direction, so these are the approximation. And they're using the following mask. These are called Robert approximation. There are also Prebert and Sobel. So these are the first derivative, then same way you do the second derivative approximation. First apply first derivative, then the second derivative. So this is mathematically we can understand first derivative graph and the second derivative graph. So you understand the information on the edge of the image. So in the image, the from black to white, the vertical line is the edge of a point that lies on the edge, can detected by local maxima, minima. Mathematically we know when the derivative equal to 0, we call it a zero crossing of the second derivative. The second derivative change convexity is an example of the calculation of second derivative. And del square we know in x direction or y direction. So this is numerical approximation. So these are Laplacian mass second derivative. Input image, if you apply Laplacian, you will get this output result. Definition of Laplacian mask also second derivative. This is a blurred image Then Laplacian mask. Here with the Laplacian and Sobel mean the first derivative. These are the result. So Laplacian localized edge better. High order derivative are typically more sensitive to noise. Laplacian is less computational expensive. Laplacian can provide edge magnitude information but no information about the edge direction. So both are applicable in different setup. Sometimes we need Laplacian, sometimes we need first derivative, like Sobel filter. These are some references. Thank you very much.